In this video I want to work a couple problems where we're asked to evaluate trig functions by first finding a reference angle and then using that reference angle to help us with the evaluation. So these problems blend two ideas that we have talked about. The first is the idea of a reference angle. You recall that a reference angle is between 0 and 90 degrees, or 0 and pi over 2. So a reference angle is always going to sit in the first quadrant. And our trig functions are all positive in the first quadrant, right? So when we use a reference angle to perform an evaluation, we need to keep in mind where our trig functions are positive and where they are negative, right? And that's something that we covered in the last video. So let's work the first problem where we want to evaluate cosine of 7 pi over 6. 7 pi over 6 is a rotation that lands in the third quadrant. It takes pi radians to get to this point, so this reference angle here is pi over 6. So what this problem wants us to do is it wants us to evaluate cosine of 7 pi over 6 in terms of the cosine of pi over 6. Right? This is going to be a positive value, but we know that the cosine is negative if we are left of the y-axis, right? So either quadrant 2 or quadrant 3. So we want the negative of the cosine of pi over 6. So negative root 3 over 2. Let's work the cosecant. We want the cosecant of 3 pi over 4. So 3 pi over 4 lands in quadrant 2, right? Making our reference angle pi over 4. So cosecant of 3 pi over 4, I want to evaluate in terms of the cosecant of pi over 4. And whenever we deal with cosecant, life is probably easiest if we think in terms of 1 over the sine, right? So this expression in quadrant 2 is going to be positive, right? Because sine of theta, our sine function, is positive in quadrant 2 as well as quadrant 1. So cosecant of 3 pi over 4 is going to be exactly the same as the cosecant of pi over 4. This is 1 over the sine of pi over 4, which is 1 over positive 1 over radical 2, which simplifies down to radical 2.